Question 6. The positions of two towns A and B on the Earth's surface are 60 degrees north, 139 degrees east, and 60 degrees north, 41 degrees west, respectively. Given that the radius of the Earth is 6370 kilometers, calculate the shortest distance between A and B, 3 marks. So we will start by locating the point A. We've been told that the point A is on a latitude 60 degrees north and then 139 degrees east. So this is where we find point A. And then point B is on a latitude 60 degrees north and then 41 degrees west. So this is where we find the point B. We are being told here to calculate the shortest distance between A and B. So let's first of all consider the value of theta. So the value of theta will be equal to the degrees on the eastern side of Greenwich, which is 139 degrees, and then we add the degrees on the western side of Greenwich, which is 41 degrees. So in total, this will lead you to 180 degrees. And therefore, since the value of theta is equal to 180 degrees, we will comfortably say that these 2 points are antipodal, or they are directly opposite. And therefore, the shortest distance between them will be through the North Pole. So we're going to move along a great circle through the North Pole. And therefore, the new value of theta will be equal to, we are moving from A and then to the North Pole, that is from 60 degrees north all the way to 90 degrees, that is 30 degrees here, and then 30 degrees from 90 degrees north back to 60 degrees north. So our new value of theta will be equal to 60 degrees. So we are going to consider our shortest distance to be distance in kilometers, and this is along a great circle, will be equal to theta divided by 360, and then we multiply by 2 pi r. And we've said the value of theta is equal to 60 degrees now, and then divided by 360, and then we multiply by 2 times 22 over 7, and then times 6370, the radius of the Earth. And therefore, this will lead us to getting 6,673 and a third kilometers. And this is the solution. Question 7. Given points X 30 degrees north, 70 degrees east, and Y 30 degrees north, 20 degrees west, and taking pi to be equal to 22 over 7 and the radius of the Earth to be equal to 6370 kilometers, calculate, and then part A, the distance between X and Y along the parallel of latitude. Roman 1 in kilometers, 2 marks. Roman 2 in nautical miles, 1 mark. Part B of the question, the local time at X if the local time at Y is 20-30 hours. Part C, the position of Z if Z is 5,700 nautical miles south of Y, 2 marks. And then part D, the shortest distance between Z and K in nautical miles given the position of K is 65 degrees south, 20 degrees east, 3 marks. Let's capture the points on a diagram. We've been told that point X is on a latitude 30 degrees north and then on a longitude 70 degrees east. So this is where point X is found, and point Y is found on a latitude 30 degrees north and then 20 degrees west. Part A of the question, you are being told to calculate the distance between X and Y along the parallel of latitude, and then in Roman 1 we are going to find that distance in kilometers. This will be distance in kilometers along a small circle. So we are going to consider that formula, that distance in kilometers along a small circle will be equal to theta divided by 360 degrees, and then we multiply by 2 pi r cos beta. And then what will be the value of theta? The value of theta will be the 70 degrees on the eastern side of Greenwich, and then the 20 degrees on the western side of Greenwich. When you add them together, we are going to get 90 degrees. So we are going to have 90 divided by 360 degrees, and then we multiply by 2 times 22 over 7 times 6370 cos. Then the value of beta will be 30 degrees, since the latitude of x and y is 30 degrees north. So we're going to have cos 30 degrees. And then when you do the multiplication there and division, the solution you're going to get is 8,668.9 kilometers. In Roman 2, we are being told to find the distance in nautical miles. So we are going to consider the relationship that 1 nautical mile will be equal to 1.853 kilometers. And therefore we ask ourselves, what about 8,668.9 kilometers will be equal to how many nautical miles? And therefore by cross multiplication, you're going to have 1 to multiply 8,668.9, and then we divide by 1.853, and this will lead us to getting 4,678.3 nautical miles. Part B of the question: calculate the local time at X if the local time at Y is 2030 hours. So we know that the value of theta will be equal to 90 degrees. So let's find the difference in time between these 2 points. We are going to say that if 1 degree will be equal to 4 minutes, what about 90 degrees will be equal to how many minutes? So by cross multiplication, you're going to have 90 to multiply 4 and then divided by 1. So this will be equal to 360 minutes, which when converted to hours, you're going to get exactly 6 hours. So I've captured an illustration here. So this is the point Y, where the time is 2030 hours. We are looking for the point X, the time at the point X, which is 70 degrees east. So therefore, the difference in time between these 2 points will be equal to 6 hours. So this is the difference in time between those 2 points. So therefore, remember the point X is also on the eastern side of the point Y, and therefore, the more you go to the east, the ahead the time. So we are going to add 2030 hours, and then we add 6 hours. So you're going to realize that the time at point X will be reading 0 to 30 hours the following day. Part C of the question. We are being told to find or to calculate the position of Z if Z is 5,700 nautical miles south of Y. So from our first diagram, we can say that Z is found south of Y. I can represent with an arrow in this direction. So let's consider where Z is found. And how are we going to do that? Let's find the value of theta, and this time theta will represent the latitude difference. And it means also we are considering that this is distance along a great circle. So distance in nautical miles, and this is along a great circle, will be equal to theta multiplied by 60 degrees. And then we've been told that the distance is 5,700 nautical miles. So this will be equal to theta multiplied by 60. And then you divide both sides by 60 so that you get the value of theta. So you're going to find the value of theta to be equal to 95 degrees. So in my representation, I've captured the point Y, which is on a latitude 30 degrees north, and then there will be the equator, and then we are looking for the latitude of point Z, which is on the southern side of the equator. So since the value of theta is 95 degrees, we are going to consider that the red arrow will be equal to 95 degrees to subtract 30 degrees, so that we get the number of degrees on the southern hemisphere. So by subtraction here, we are going to get our answer as 65 degrees. So this will be south. By conclusion, we can say that the point Z is on a latitude 65 degrees south and the longitude 20 degrees west. Part D of the question. Calculate the shortest distance between Z and K in nautical miles, given that the position of K is 65 degrees south and 20 degrees east. Now I can represent the position of point Z in my diagram. I know that Z will be on a latitude 65 degrees south and then on a longitude 20 degrees west. So this is where we find point Z. And then we are told that K is also on a latitude 65 degrees south and then on a longitude 20 degrees east. So let me capture the longitude here. This is 20 degrees east. So this is where we find the point K. So we are being asked to find the shortest distance between these 2 points. Definitely it will have to be along a small circle. And this is because of the fact that the value of theta here is less than 180 degrees. And what is the value of theta? Theta will be equal to 20 degrees on the western side of Greenwich plus 20 degrees on the eastern side of Greenwich. So when we add 20 plus 20, we're going to get the value of theta to be equal to 40 degrees. And therefore, in considering the shortest distance, we are going to consider that distance in nautical miles along a small circle will be equal to theta multiplied by 60 cos beta. And therefore the value of theta is 40, and then we multiply by 60 cos, and the value of beta is 65 degrees, the latitude on which those 2 points lie. And therefore by multiplication, we are going to get our answer as 1014.28 nautical miles. And this is the final answer. Question 8. 2 towns X and Y lie on the same latitude in the southern hemisphere. When it is 9 a.m. at X, the time at Y is 11 a.m. Part A of the question. Given that the longitude of X is 12 degrees east, find the longitude of Y, 3 marks. Part B. A plane leaves X for Y and takes 2 hours to arrive at Y, traveling at 600 kilometers per hour along the parallel of latitude. Find, Roman 1, the radius of the circle of latitude on which town X and Y lies, 3 marks. Roman 2, the positions of the 2 towns, 4 marks. The first step we need to consider is locating the points on the Earth's surface. So I've considered the fact that point X and Y lie on the same latitude on the southern hemisphere. And then we've been told that when it is 9 a.m. at X, the time at Y is 11 a.m. So that means Y is on the eastern side of X. So in part A of the question, we are being told that given that the longitude of X is 12 degrees east, which I've already represented here, find the longitude of Y. To find the longitude of Y, we need to consider the time difference between the 2 points, which we've been told is equal to 2 hours. And therefore these 2 hours can be converted into minutes by multiplying by 60, so we end up getting 120 minutes. So therefore we say that if 1 degree will be equal to 4 minutes, what about 120 minutes will be equal to how many degrees? So on cross multiplication we are going to have 120 to multiply 1 and then divided by 4, and we're going to get our answer as 30 degrees, and therefore the value of theta is equal to 30 degrees. Now to find the longitude of y, we know that the longitude of x was 12 degrees east, so we're going to add 12 degrees east plus 30 degrees, and therefore the longitude of y will be 42 degrees east. Part B of the question. We are being told that a plane leaves X for Y and take 2 hours to arrive at Y, traveling at a speed of 600 kilometers per hour along a parallel of latitude. And then we are told to find in Roman 1 the radius of a circle of latitude on which town X and town Y lie. So to find the solution to this question, we are going to consider the fact that distance xy along a small circle will be equal to speed times time. So we've been given the speed there to be equal to 600 kilometers per hour, and then we multiply by time, which is 2 hours. So therefore the distance will be equal to 1,200 kilometers. And then as far as the radius of a circle of latitude is concerned, we are going to consider the following. Remember that distance along a small circle, we can also refer to as along a parallel of latitude. So therefore we can say that distance in kilometers along a small circle will be equal to theta divided by 360 degrees times 2 times 2 pi r cos beta. So this is the formula for distance in kilometers along a small circle. But then remember we said that the radius of a latitude will be equal to r cos beta. So in this formula we need to make r cos beta the subject, and this will give us the value of the small r, or the radius of the circle of latitude. So we are going to consider that the distance now is equal to 1,200 kilometers, and this will be equal to the value of theta. We had found it to be equal to 30 degrees. You're going to have 30 divided by 360 to multiply by 2 and then by 22 over 7, and then let's find r cos beta. So when we perform operations on these numbers, you're going to get our answer as 0.524, and this we are going to multiply by r cos beta to be equal to 1,200 kilometers. And therefore when you divide both sides by 0.524, we are going to get the value of r cos beta to be equal to 2,290.9 kilometers. And this is the solution for the question. In Roman 2 of the question, we are being told to find the positions of the two towns. So to find the position of the two towns, we are going to consider finding the value of beta, because beta will lead us to getting the latitude, which is on the southern hemisphere where the two towns lie. So we can as well use the information that we have here, that 2290.9 kilometers will be equal to r cos beta. And you know r, or capital R, will represent the radius of the earth. So you're going to have 2290.9 kilometers will be equal to 6370 cos beta. And therefore we can divide both sides by 6370, sorry. We can divide both sides by 6370, so that we get the value of cos beta to be equal to 0.3596. And therefore finding beta will be equal to 68.92 degrees. Therefore, the town X will be found on a latitude 68.92 degrees south, and then 12 degrees east. And then town Y will be found on a latitude 68.92 degrees south, and then 42 degrees east. And this is how we answer these questions. Let me say that in this topic I've tried to simplify the laws involved, and I've also considered some 8 questions to show you practically how we can apply some of the laws in answering of questions. No student should have to find it difficult to participate in mathematics activities. My name is Dr. Titus, and this is a Doc Mathematics.